Welcome everyone to the exciting fireside chat that we have today from EcoITCon. And the topic for today's chat is designing for sustainable architecture and what do you need to look at when you are designing software systems, and does architecture even play a role there? And to give insight around this topic, we have Vivek Kant. Vivek Kant is one of the well-known faces in the IT industry, in architecture and technology space. He's currently the CTO at Bajaj Markets. Bajaj Markets is part of Bajaj Financial Services and is also responsible to look at a diversified marketplace from a financial standpoint. Welcome to our chat today, Vivek, and thank you for spending so much time with us.
Thank you, Archana. My pleasure.
Yeah. To give you listeners a little bit more background about Vivek, Vivek is a hardcore technologist. I've been fortunate working with Vivek during my career, where I've seen him playing multiple roles in terms of coder, technologist, architect, digital transformation lead, and so on and so forth. And when I was considering this topic, I thought he would be the right person to address our audience on what does it mean for a technology and architects, and how do they go about addressing this whole wide abstract topic of sustainability and bringing that into software architecture. So with that, let me get started with my first question to you, Vivek. Today, sustainability is riding its wave. Everybody's talking about it, but not so much so from a software standpoint. You do hear sustainable technologies, but when you talk to software engineers, you don't really hear that on their top of the mind agenda. So from that standpoint, can you start by telling us what does it mean to be green in a software standpoint, and what do we need to look at it?
No, absolutely, Archana. And software architecture, probably sustainability is not something which comes to the mind. And specifically, the only thing comes to mind is that digitization enables reducing the paper, reducing the physical, effort, and hence reducing the carbon footprint. But from a software perspective, aspect of green software or a sustainable software is something which is not very prevalent even today, while there is a massive wave and massive consciousness that is around the sustainability. But actually, if you look at it today, a large part of our life revolves around softwares, whether it's the enterprises we work in or even around our personal life, social media devices. Hence, since software is running everything, aspects of green or sustainable softwares are extremely pertinent at today's time. And if I just elaborate, the green software architecture would primarily, I look at three different aspects. The first aspect, which is very obvious, is the green or the energy efficiency of the software. How energy efficient a software is. We are very used to seeing energy efficiency in the electrical appliances we use. But have we even thought about how, when we design a software as architects, as technologists, how energy efficient our software is? The second obvious aspect of this is that if we take any software application, what is the lifetime energy consumption of that software or a business application is? And that is very important. And sometimes, while the application, when it is designed, it's very efficient, but over a lifetime, the consumption, there are various factors that decide how efficient or how green a particular software is. And third aspect, which I would like to delve a bit in detail around the green principles of software architecture. While we have looked at enterprise architecture principles and various other software architecture principles, green principles is something which is relatively new and not very well understood. So maybe we can spend a bit of time delving into what are the green principles and how do we look at software architecture when we are building it, that it is energy efficient and sustainable in a long run.
Thanks for that, Vivek. I really like the aspect that you mentioned, that one is designing the part, which is important, but equally important is to say how is it performing over a lifetime. Because as you rightly said, there will be different factors on how it is doing in runtime, what is the changes, if upgrades happen, how does the software actually behave. And I like the analogy that you brought in to say, okay, today when I go and buy an electrical appliance, I see a star rating and I would say, okay, this fridge or AC or any washing machine, I will look at that star rating. But when I go and buy a software, can I look at a star rating? Perhaps not. So that's an interesting analogy. And I do wish that we can in the future see some such ratings in our industry as well. But going further to say, okay, while designing is important, looking at runtime is important. Today, when an architecture starts of a software, that's one of the first thing that an software systems architect or somebody who's leading that whole and strategizing that whole system does. But they don't have any guidelines today. They don't have any considerations today to look at what does it mean to even design an energy efficient software. So could you go deeper into those principles and tell us a little bit about what could they look at when they start designing?
Sure. So when any good architect designs a software, so far what we have done is we have looked at the software to optimize the performance, primarily to drive a customer experience. Focus of designing a software is that it should give the best possible customer experience. So if I look at web applications, what is the page load time? What is the time to interact? Those are the things that we typically look at. And whether when a large number of users use that software application concurrently, how does it performs in load, in peaks, in spikes? These are the things we were looking at. Also, the second factor now, because most of the digital applications are hosted in cloud, the second factor which has been looked at is the cost of those applications. A particular application for a set of load requires a certain infrastructure. And the second order optimization after the customer's experience comes is the cost of those applications or the infrastructure that this application is running. So if a particular application is taking X virtual machines, can I reduce by 20%? And software optimization is focused on reducing the infrastructure cost. That is the second order design. But what I have been seeing and my experience in my own organization has been a lot of focus is still on reducing using the bill. I actually do not reduce the cost of the software architecture or the cost of the infrastructure by reducing the footprint. I reduce it by using my billing levers per se. So what it does is basically it reduces my cost, but does not reduce the footprint of that software. So now I think we have to look at things that are really will reduce the software footprint, which means the infrastructure that it uses. And in turn, of course, the sustainability of the software. Another important point which I mentioned earlier, and is around the lifetime value. So I'll give you a very simple example, and then I can go in bit detail around the various principles. So today, storage is something we take for granted, and in fact, on cloud, a very large volume of storage and archival storage and file storage is available to us. So we don't even think about those aspects of whether I need to archive certain data, whether I need to purge certain data. We keep it forever because it's easy, it is cheap. But if you look at it, I come from the time I have seen the backups used to be on tape, which was most energy efficient. Yeah, tapes do not consume any energy. But we have moved, most of the technology has moved to disks, which are always on. So which means if you store a certain, a terabyte of data stored will continue to consume energy, even if you are not using it. So lifetime cost, things like how much data I store and continue to store a period of time has an impact, if not on cost, because storage is cheap, but it has an impact on the software energy footprint. So even simple things which we used to do earlier in terms of data purge, of course, we have regulatory guidelines in terms of how long we have to store the data, but beyond After meeting those regulatory guidelines, do I really need that amount of data? Should I parse that data? And also, looking at cloud providers to go back to zero energy archival solution, deep archival solution is something we should need to look at. Now, coming back, so this is one example that we now, because of it's easy and it's cheap, we do not consider the energy or the ecological impact of the softwares that we are running and the massive amount of data that we are generating and continue to store forever. If I look at some of the principles, so a lot of these applications today in digital space are designed on microservices. Some of the levers that I have also applied that has, besides improving the customer experience and reducing the cost, has significantly reduced the footprint as well. We utilize a lot of caching capabilities and CDNs, because that reduces the footprint by reducing the number of server calls we do, and it reduces overall the network calls, the server calls, because it reduces the energy footprint of the software. Some of the important things that we have been able to do is compute optimizations. So earlier, when compute was very expensive and memory was very expensive, we used to do massive optimizations on our software to make sure we are able to derive complete performance of our software on a very small we used to pride ourselves in running a very high load applications on a simple Pentium chip, 1 GB RAM server. So we still have to go back to that. We need to go back to those principles and look at doing compute and memory optimizations like we used to do by load testing, by going through our softwares once it's built, and even at a design time understanding how can have a complete optimization of the software. And of course, besides it being sustainable, the side benefit is that it will give you reduced cost and better customer experience. Also, in terms of one of the other things I have seen and in some areas we have implemented is usage of event-driven architecture. Synchronous applications, and specifically in microservices, what happens is that I will have multiple layer of services, and a single customer request ends up in multiple network hops between microservices. And each of these microservices has, uses compute and memory. So how do I optimize that? So event-driven architecture is something that reduces the number of round trips. It makes it asynchronous, and it has a tremendous, over a magnitude benefit in terms of compute organization optimization, because then I can actually scale I don't need to have very large. So for example, for a synchronous application, if I have a peak of 4x, then I need to have 4 servers, ability to run 4 servers to be able to deal with that daily peak. If I say, even with Elastic, it's daily peak, I still have to run. But with the event-driven architecture, a lot of these peaks get flattened because of the buffering capability and response and ability to manage the customer experience around it. So event-driven architecture is significantly more energy efficient than a synchronous always-on architecture. Another important thing which I am seeing in the industry is, even though we have cloud capabilities, a lot of these architectures are still designed like they used to in a on-premise data center model. A good example is the disaster recovery for it. For, as you know, the financial services, critical applications in financial services industry have to have disaster recovery. It's a requirement. But how do I design that? Do I have complete redundant infrastructure in a DR, even if half the scale, and continuously running that? Is that most optimal? No, certainly not. So now with public cloud and various technologies of data replication, we have the ability of running complete active architecture. Now the advantage of an active architecture is it's a massively more optimized and low cost. So what happens is, if today I have, I give an example of AWS, a server in Mumbai, I can have a server in Hyderabad as well. And I can actually redirect a load on both the servers. So both the servers, even though I have a DR, my DR is fully utilized while it is running. So it reduces the footprint significantly. So active model of DR is a massive cost saving of production infrastructure, as well as, reduces the footprint of the software I have. So these are some of the principles which are, not very difficult to implement. And besides reducing your footprint, energy efficiency, increasing the energy efficiency, reducing the footprint, the benefit it has obviously is the reduced cost. So that is a side benefit, even if, that is not the primary goal, it's a side benefit. And all of these interventions make the software more robust, resilient, and scalable as well. So it gives better customer experience. So it's actually, if I say software efficiency, or making sustainable software is not a trade-off against anything. Actually, it is just a focus that we need to do on it, and it's actually a win from customer experience perspective, win from cost perspective, and win from a sustainability perspective.
Yeah, lot of pointers that you've given, Vivek, but one thing I think that is extremely important that you brought out, that it is a win-win for all the three. Because whenever a sustainability conversation comes out, typically people think that sustainability is at the cost of something else. It could be, for example, I still remember one of the conversations I was having where one of the things that the developer were doing is the white screen, black screen, and typical things that white consumes more energy, black kind of colors, dark colors consume lesser. And the conversation there was, what if I like those lighter colors? Why should I go it just for a sustainable thing, right? But these, and in somebody's mind, sustainability is always a trade-off. I may not be able to wear great clothes because, hey, you know what, if I wear that clothes, it might affect the environment because I'm asking them to create some more new designs for me, right? And continuously, if I keep on buying, it's going to cost, right? So when you have that kind of mindset which exists, which looks at sustainability from a distance, there is also a mindset which says sustainability is charity. It's not necessarily good business. But what the point that you brought out is that it's not necessarily so. Don't look at it as a trade-off where you have to forego some of the things that you want to do. Neither look at it as a trade-off saying that it's a charity and you have to do it as tick in the box. But if you truly design the way you spoke about in terms of looking at architecture from customer experience, performance, usage of optimal memory standpoint, moving to how you are looking at disaster recovery setups and settings for your cloud, the whole thing kind of comes together to truly give a win-win experience right from a customer standpoint to a good business sense. And of course, making sure that we leave a better legacy for the next generations to come. And I truly like that point, because in my mind, looking at it as a win-win, somewhere it always used to be a trade-off. So if I expand that a little further, what do you think an architect should start? If I say 2-3 questions an architects may want to ask themselves when they start designing, what would those questions be? What advice would you give to those architects?
So my advice will be actually very simple. So go back to clean software, clean code practices, and first principle decision making. So when I build a software, how do I build a software that's most efficient? And there are great people who have in some of the within the industry, I know, and there are various one of the largest brokerage in the country, the CTO of that company has given multiple talks, that ability to run massive amount of data processing in extremely low powered commodity computers. So primarily, it's go back to first principles. Look at think about that. We are not with cloud and with the computing power on tap. Let's look at our ability to design a software that's most efficient as a primary first level, first order architectural goal. If you do that, everything else falls in place. So the customer, as I said, it's not our trade-off. Customer experience, performance, scalability, resilience, everything will fall in place. So go back to first principles of software architecture, software design, and let's build a most efficient piece of software that there is. If we start with that objective and goal in mind, I believe everything will fall in place.
Yeah. And expanding that little further, Vivek. So let's say the architect comes with that objective, does in fact design it, but the vision of the architect gets realized by the engineers and developers who actually code and develop on it. How do you bridge that gap so that there is no loss in translation from the vision that the architect has? Because if you go and talk to a developer saying, do you understand principles of green development, sustainable development? Perhaps not. They may not know. So how does an architect play a role there
I
to
think
bridge this gap?
absolutely very, very valid question. And I think one of the biggest challenge today we have is that while there is a lot of good talent in our industry, in terms of education and efficient software design, clean software design, clean coding, it is still, leaves much to be desired. So I think a tremendous effort has to be made in developer education and ensuring they understand the implications of the software that they write. And the only way to get through them is involve the developer community as part of the software design process itself. Today, a lot of still the SDLC process we run, it's still hands off. So even though we went into agile model, it's still handoff between architect to a tech lead to developers. And so instead of these hands off, it becomes more a community development, and also have a technology community within each organization that talks about these topics and beyond the work, and as a community, that this is what is important and this is how we should focus, because that's how we want to move in future together. So I think the education, community building, these are the things that I think can help take it to the developers who will actually the ones who will write the code.
Yeah, thanks for that, Vivek. So we spoke about need for the green software. We spoke about some of the principles. We also spoke about how the architects can bridge the gap which is there. So coming to one of the other points that you referred to was that this is all designing, but it's also important to look at the runtime aspect of how the software is performing over a lifetime.
Yeah.
What would those aspects be? What should somebody who is monitoring that software in an operation setup look at to say whether the software is truly green or not?
No, I think that's a very important point, because today what happens is something goes live. The only time, architect looks at it when it breaks. When it's not working, then then we have that attention. So I think what I call is continuous performance engineering is something which is need of the hour. So look at software, running software, not just from a functional perspective, and but also review the software from a performance standpoint continuously. So today what we do monitoring, and
correct.
The monitoring we do primarily, thresholds and alerts is what calls for action. Do not do performance engineering of an existing application's performance review of an existing application continuously. That is what is needed. So we should have maybe monthly, quarterly reviews of existing software from a performance and sustainability standpoint. And look at because what happens is it is even if the software is developed and implemented right first time, it is the small delta changes that happen over a lifetime that makes all the difference. So I think continuous performance engineering is the need of the hour, and that's what helps us ensure that that a sustainable software implemented remains sustainable.
Correct. So one of the last things that I want to ask you is that as a future in the industry, do you see sustainable software architect as a tag or a designation which people will carry? And to truly get to that, what do the industry needs to do today?
So I think 2 points. Of course, I would probably not call a tag, but what I would say, I would like to see, software architects or solution architects, enterprise architects, they should, mention in their resume that we care about sustainability, and we, the softwares we design and build are sustainable. But more importantly for industry, I think what is completely lacking today is any objective benchmark and standards. Because without the benchmark and standards, it's very difficult for people buying softwares to make the right choices. And it's the buyers and their push to the industry which drives the industry and the change. So the example that we started with, the electrical equipment and air conditioners and refrigerators. So the ICER rating, the star rating that we see actually has made tremendous difference. Because their rating has become a very important factor in consumer choices. And it's their buying decision that has driven the manufacturers and OEMs to produce more energy efficient equipment. Now, what we need today in the industry is starting with two things. One, the package software or any of the softwares, like for example databases. So these software should come with certain standards of where consumers can measure and objectively know the energy efficiency of these software. So for example, a particular relational database running a particular workload, what is and on a certain device, what is the energy consumption of it? So I should be able to, if I am making a choice of database today, all the decisions are technical and functional. But if I have that knowledge that how efficient a particular database is, then it helps me make the right choice. And secondly, from cloud perspective, which is happening, we need more transparency and data to be available in terms of the overall footprint and overall energy being spent on any workload that we deploy on cloud. So more transparency, more data, more decision, objectivity in decision making will help the consumer make the right choices. And once consumer starts making sustainable choices, the manufacturers or the creators or the industry providers will have to fall in line and focus on energy efficiency and sustainability as the first order problem and a first order solution.
So if I try and summarize in a nutshell, one, during designing, architects should play a major role, and along with their performance, cost, and those kind of considerations, bring in the sustainability aspect out there. Because if you design that way, it's not just good for your customer experience, it's not just good for your business, it's also good for your earth and the ecosystem that we are living in. So that's the first. And second thing which is there is, as an industry, we need to do a lot more, right from educating the developers and the talent that we are building to the aspect that how can we bring objectivity and transparency, so that when we are going and buying a software, and increasingly, as you rightly said, with digitalization, it's all about software and buying and doing that. Can it be as simple the way today our ICER star rating is, where even small kids understand what those 5 stars and 3 stars and 2 stars mean? Whereas today, there is nothing of that sort in the software industry. So there needs to be a lot more to be done from regulatory standpoint, from standardization standpoint, where we need to work with the policymakers and the creators of the software industry need to come together to define some of these things. Great insights, Vivek. Thank you so much for talking about these things. And we would love to have you back to explore some of these topics greater in detail as to how do we really go about doing some of these things in action. Thank you so much for joining us today.
My pleasure, Rachna. Thank you for inviting me.
Thank you.